Hello everyone, this is Nilesh here once again. After learning object-oriented concepts in C#, now it's time to talk about delegates and events. Typical implementation of delegate and event is unique in the C#.NET, which is not commonly seen in other object-oriented programming languages. In this particular session, we will discuss about the delegates thoroughly. We will talk about what is delegate. We will understand the basic delegate concept and multicast delegate. Alongside delegates, we will also talk about the related topics like anonymous method or Lambda expressions. So let us ask the first question. What is delegate? Talking about delegate is an object-oriented function pointer. So delegate is user-defined reference type. We can create object of delegate and initialize it to the address of a function. And then using the delegate object, we can invoke the function instead of directly invoking it with the function name. So how we can proceed with this delegate? Of course, very first thing, you should be having some function in front of you. The function to be invoked via delegate. Let's take an example of an add function given over here. Then to declare the delegate object, you need to first define the delegate type. The delegate type is defined with the delegate keyword. And after delegate keyword, I need to write the return type of the function, and then it is a name of the delegate, and then argument types. Please note that this particular signature must match with the function whose address you want to keep in that delegate. Now, this is just a data type. To create the actual object, you need to first declare the delegate reference, and then you can create the delegate object using the new operator. You recall that the reference type objects are always created using new, and those objects are stored on the heap. While creating object, I can specify the address of the function as an argument. And if you put it diagrammatically, it will look like this. In this particular case, you will find that the PTR is a pointer, which is actually referring to the delegate object. And this delegate object is going to hold the actual address of the function. Now, once we have the delegate object pointing to the function, we can call that particular function just like a normal function name. So I'm simply saying PTR 22,7. What will happen? In this particular case, it will eventually make a call to the add function, and 22 and 7 are passed as arguments A and B into the function, and then the function is executed. If function is having some return value, then that return value can be collected over here. Currently, we are dealing with a void function. Let us try this practically. So let me take you to the Visual Studio. And in Visual Studio, I have already created one blank solution, event delegates. So inside this, let me create a new console application. Let me call this as delegates. And then I will click on next. Now, we want to declare one delegate type, and then we want to write some function, and we want to initialize the delegate object to that particular function address. Let us continue with the same example. Let's say delegate void, I name it as math operation, and this will take two arguments, integer A and integer B. Now, once this is clear, we can write one function. Let's say static void. Let's say I'm writing add function with value A and B. And inside this, I will do a very basic level operation like result is equal to a plus b, and then I can print the addition result over here. You can keep this function private, protected, or public as per your requirement. Now let me declare a delegate reference, math of ptr. I can initialize this reference to a delegate object. ptr is equal to new math op, and inside this I want to pass the address of any function who is returning void and taking two integers. Yes, add function I can use it, but have you noted that this add function is a static function of the class? In that particular case, I can use program.add because we always call the static function without creating the object of the class. And now it's time to actually call the method. That's it. Let me try to run it and you can see the output. I hope this is working fantastic. You can also try to debug this code. And while debugging this code, you can see that ptr22,7 is actually invoking my add function. That's wonderful. Now, can we initialize only the static function address to a delegate? Answer is no. You may also have non-static function. Let's consider that I'm writing another class. Let's say mathUtil class. And inside this mathUtil class, I want to write a function called as a subtract. This function is taking two arguments, a and b. And inside this, I'm writing similar logic once again. So let me print the subtraction over here. Now, how I will be able to create a delegate which is pointing to this subtract? Well, this is a non-static method. So non-static method is always accessed using object name dot method name. So in this particular case, I need to create another pointer, let's say ptr2, and that is equal to new math operation. Inside this, I need to use object name dot method name. For that, I have to first create the object of mathUtil, and then I can use obj dot subtract. Will this be able to call our method? Let us give a try, and you will find that this will exactly call the same subtract method. Let me debug it step by step. At this moment, when I say F11, it will jump into the subtract function, and this subtract function is called on the given object obj. After invoking the method, it will display the result and then it will return back. So I shown you how you can initialize the delegate object using the static function or non-static function. Well, what about going with a local function? Is that possible? Answer is yes. So let me define one local method, and my local method is void, let's say multiply. Again, I will have integer a, integer b, and we will write the similar logic once again. Let me print the multiply result. Now I can create one delegate object and it will refer to the multiply method. So math of ptr3 is equal to new math op, and I can pass the multiply directly here. Now you can make a call to ptr3 and let me pass similar argument once again. What will happen In this particular case, let us debug it and cross check that. When we will call ptr3 over here, it will actually invoke the multiply method, and 22 into 7, the result will be 154, that is displayed over here. Please note that this particular method can be static or it can be non-static as per your requirement. Have you noted that all 3 times I have initialized the delegate reference using the new operator? Now let me tell you, the C# 2.0 and onwards, writing this new math op is not compulsory. Meaning by you can directly initialize the delegate reference to the method name. What exactly I mean? Let me show you over here. Let me write another method, let's say divide. And in this divide method, I will divide a by b. And whatever is the result, I will display over here. You may use double or you may use integer depending on your requirement. Now, I can directly write math of ptr4 is equal to divide. This is absolutely valid. In this particular case, internally, new math of object will be created and it will be given address of the divide. And then ptr4 we are calling with arguments 22 and 7. Let us make a call and test it once again. I'm debugging this. When I'll make a call to this ptr4, it will execute the divide method. Currently 22 divided by 7, integer divided by integer, gives me only integer, and that's why the result is only 3. That's it. So we understood that the delegate object can point to a static method, can point to a non-static method. It can also point to the local method, or it can also be initialized without a new keyword. But now we can go ahead and we can learn some real cool uses of this delegate. The delegate also brings a new concept called as the anonymous methods. So instead of creating a method with some name and then assigning it to the delegate, I can have one delegate object which is directly pointing to some method without any name. That is anonymous method. You can see the example over here. We can type this full example and test it. Let me try the modulus operation using anonymous method. So math of, let's say ptr5 is equal to write anonymous method, you need to use the delegate keyword. And then this delegate keyword, you will have the arguments, maybe integer a and integer b. And then we can write the curly bracket, and inside that we can perform the operations as per our requirement. And finally, I can print the result. That's it. In this particular case, whatever method we have defined over here, it doesn't have any name. That is the reason it is called as an anonymous method. But that method will have some memory and its address is stored in ptr5. Now we can call this ptr5 with again same arguments. Let me set a breakpoint and debug it. Again, I will use F11 and you will see that it will jump to the anonymous method. It will execute that 22 by 7, remainder will be 1, that is displayed over here. Now we can make this method further shorter, and that can be done using a very special syntax called as lambda expression. So let me do similar sort of work once again. Let me start with the math of ptr6 is equal to, but instead of using delegate keyword, I can directly start specifying the arguments. Let me specify the arguments a and b, and then the method definition can be written after the curly brackets. Inside this, let's say I want to find out maximum of these two numbers. That can be found quickly by using int.max, and I will pass AB. Then I can print the result. Let's say maximum is equal to result. You can call this with the same arguments once again. Let me again set a breakpoint and debug this. I will use F11 and you will see that it is actually executing this multi-line lambda expression. Something very interesting to watch over here. We have not given any argument types over there because these argument types are automatically inferred, automatically guessed by the compiler looking at the delegate declaration. While we declare the delegate, we have mentioned that this delegate will have both the arguments of type integer. And that is the reason automatically this A and B is considered as integer. We can see the result of this method over here. Though we can write such multi-line lambda expressions, it is very common to write the lambda expression with the single line. And let me demonstrate you the same. We can do the similar job in a single liner. And when we go for a single liner, these curly brackets are even not required. So let me go for math of ptr7 is equal to, I'm passing a comma b, and then directly I want to print the minimum without declaring any variable because I want to complete everything in a single line. So let me write console.writeLine, and inside this I will mention that minimum is equal to minimum of these two values. So I can directly call int.min over here. It is a comma b. That's good. And then ptr7 I will pass the same arguments once again. Let me debug it once again. And now you should be able to see that it is directly jumping to the single liner lambda expression. This kind of syntax is also referred as expression bodied syntax because the whole expression, whole definition is written as a single line expression. Now that you have understood how this particular concept will work, let me take you to a next concept. And in this next concept, I want to talk about combining these delegates together. Well, how I can combine these delegates together? There is ready-made plus equal to operator available in the delegates. So this ptr plus equal to ptr2. And likewise, you can say ptr plus equal to ptr3. And this way, you can combine multiple delegates together. Let me club all of them at once. Once I combine all these delegates together, a single call to the ptr will internally invoke all the functions one by one. Do you want to see that? Let me show you over here. Let me make a call to the ptr, and again I'm passing the same values once again. Let us give a try whether this is generating the similar result once again. Let me run this and you see the output. Have you noted that all these 7 functions are called in just a single call from here? If you want, you can try to debug this. Let's say I'm saying F5 and then F11 is executing my first method, and then you continue doing F11, it will execute the second method, and then the third method, and then the fourth method, and then the fifth method, and then the sixth and the last one, all these methods are executed. Do you know what this particular concept is called as? This particular concept is referred as something called as multicast delegate. So you will find that whenever I created the object of method, by default, it has created a multicast delegate, and using plus equal to, I added the multiple different delegates, multiple different object-oriented function pointers in the delegates invocation list. So let me show you diagrammatically. So when I'm creating a delegate over here and adding like plus equal to subtract, plus equal to multiply, plus equal to divide, what will happen? The PTR itself will actually point to a delegate object. And this delegate object is one multicast delegate. So it will internally point to a delegate object which is holding one invocation list. This invocation list is having the pointer to all other delegates, and each delegate from this will refer to the respective function like add, subtract, multiply, divide, and so on and so forth. I guess we should take a look at this multicast delegate once again. Delegate instance that holds references to multiple methods is called as multicast delegate. When delegate is invoked, all methods are invoked in the order in which we have added the methods into the delegate object. In the same order they are executed. We can do this kind of addition using plus equal to. At the same time, I can use minus equal to for removing certain methods from that. If you want that, let me quickly show you that as well. Now, let me remove few methods from this by using ptr minus equal to. Let's say I'm removing ptr2, or ptr minus equal to, let's say I'm removing ptr4, or I can remove one more, let's say ptr6. So out of 7 delegates, I have removed the 3 delegates. So only now 4 delegates are left in the invocation list of ptr. So let us call ptr with 22.7 and let me run this. Do you see that only 4 functions are executed over here? I guess that is really interesting concept. By the way, what exactly happen when we create that delegate type? The method is a delegate type that we have created. For your information, whenever we are declaring a delegate type, that delegate type is inherited from system.multicast delegate, and that system.multicast delegate is in turn inherited from system.delegate. So whatever method that we have declared, you will find that that method is inherited from something called as a multicast delegate, and that is further inherited from system.delegate, which is in turn inherited from system.object. You can use the getType method to see the type. Anyway, this system.delegate has got some of the very useful methods. I strongly recommend going to the MSDN document and referring that. But for time being, let me tell you 2 methods out of this, especially a combine method and remove method. Whenever we are using plus equal to, internally it is calling the static method delegate.combine. So writing the ptr plus equal to ptr2, this is equivalent to writing the delegate dot combine, and we can have ptr and we will have the ptr2. So these two are combined together to create a new delegate. And on the similar line, whenever we are doing minus equal to, it is internally calling delegate dot remove method. Well, if you have noted, in this particular example, my return type was void. So my method was not returning any argument. But you ever wondered what will happen if the method is returning some argument? In that particular case, calling one PTR over here will internally get which value? So let me tell you, in that particular case, it will return only the last value. Let me demonstrate you. So what I will do is I will create a new main and we will write all together a new delegate type, which is going to return some value. So let me write delegate type, which is returning some value. So math returning operation. And this will again take the value A and B. Both are integer type. Now I want that this math returning of, let's say PTR, is pointing to, let's say, add method. Now I will prefer to write a single liner, lambda expression. So it is A comma B, and this will simply return A plus B. Please note, it is expression bodied syntax. It is just an expression. There is no need to even write a return statement over here. In this particular case, whatever expression calculation is done, it is implicitly returned from this particular method. Now, I can continue further and add another one. There, let me declare the second one, which is now returning A minus B. And then similarly, I can go for the third one, which is A into B. I hope this is okay. Now, what will happen if I'm calling PTR over here? Which value it will return? As I said that by default, it will always execute the last one in the series. Let us verify it. Yes. Please note that even though it has executed all these three things internally while returning, it only return the last value. In this particular case, it cannot return all return values at once. If you want to collect the return value of each and every function in the delegate invocation list, then you need to invoke these functions manually. And for that, you need to first access the invocation list, which can be done by using get invocation list. Please note that it is returning the array of delegate type. Now I can use a for each loop. So for each math operation OP in get invocation list, we can call each method independently. Let's say I want to call the method with 10 and 3. I will collect each result and then I will print the operation result over here. Let us give a try. You can run this. Yes, you see that all these three are invoked independently and each method return value is collected and displayed. But let me tell you frankly, the most common case where these multicast delegates are used, we usually have the return type void. And you will see the practical use case of this multicast delegate in the events that we are going to talk in the next session. So in this particular session, we talked about what exactly the delegate is. It is object-oriented function pointer. And then we seen the different syntaxes where delegate can be initialized to different methods or anonymous method or multi-line or single liner Lambda expression. We also learn that we can combine multiple delegates into multicast delegate, and then we can directly call all the methods in multicast delegate invocation list in a single call. However, if you want to collect the return value, then in that particular case, you have to access the invocation list separately and execute each function one by one. I hope you find this particular concept very important. Before we go on to the next event session, do not forget to practice this delegate concept properly, because the event is just a little twist in the concept of delegates, specifically multicast delegate. Thank you for listening so patiently. See you in the next session. Bye-bye.